Hello everyone, welcome to TV Math Hub. In our today's session, we shall be talking about question number 12 for Wakisha joint mock. It says, find the locus of the complex number z such that the magnitude of z minus 1 over z plus 1 is equal to 2. So we shall look at the solution. So we are given that magnitude of z minus 1 upon z plus 1 is same as 2. So if we have magnitude of this, we can still write this as magnitude of z minus 1 divided by magnitude of z plus 1, and this will be equal to 2. You remember that if you have magnitude of z1 over z2, this is same as magnitude of z1 divided by magnitude of z2. So likewise, we can do this if we have that. So from here, we can say magnitude of z minus 1 will be equal to 2 times magnitude of z plus 1. So we shall let our z be in the form of x plus iy, since z is a complex number. So it means we shall have magnitude of x plus iy minus 1, which is equal to magnitude of z of x plus iy plus 1. And from here, we can have this as x minus 1 plus iy, which is equal to 2 times magnitude of x plus 1, then plus iy. That is when we try to rearrange to have imaginary part alone and the real part alone. So from here, we shall remove the magnitude sign. So the magnitude sign, magnitude of a number, we recall that magnitude of z is same as the square root of x squared plus y squared. That is if z is of the form x plus iy. So likewise, if I have this, I can say magnitude of this is same as taking the square root of x minus 1 squared plus the imaginary part, that is y squared. This is same as 2, then square root of x plus 1 squared, then plus y squared. Now from this given point, we can remove the square root signs by squaring on both sides. So we shall square here, and we shall also square this side. So when we square here, we shall be able to remain with x minus 1 squared, then plus y squared, which is equal to 2 squared, that is 4, into x plus 1 squared, then plus y squared. We can try to simplify this expression, and we shall be able to get x minus 1 squared will actually give us x squared minus 2x plus 1. Then we are adding there y squared, and this is equal to 4, which is into x plus 1 squared, that is x squared plus 2x plus 1, then plus y squared. So that is what we shall get when we try to remove the square root signs. Now from there, we shall try to simplify this expression, and this will be same as x squared minus 2x plus 1, then plus y squared, which is equal to 4x squared plus 8x plus 4 plus 4y squared. Now from this given point, we can try to correct like terms. So we have x squared this side, so we shall bring all these into the other side. So x squared and 4x squared. So we shall get 4x squared minus x squared, that will be 3x squared. Then 2x, when it comes this side, it will become 10x. Then when 1 goes the other side, it will become 3. When y squared goes the other side, it will become 3y squared, and this is equal to 0. So from here, we can have this as x squared, then plus 10 upon 3 of x, plus 1, then plus y squared, which is equal to 0. We can try to rearrange this further to have x squared plus 10 over 3 of x plus y squared, then plus 1, which is equal to 0. So we need to know or to find the locus of the complex number. So to find the locus, we need to know what exactly this represents. But of course, looking at this, it represents the equation of a circle. So we can find out more by getting the radius and the center. So for that case, we shall try to use completing squares here. So this is x squared plus 10 over 3 of x. We shall add there the half of the coefficient of x squared. So when you get 10 over 3, then divided by 2, you will remain with 5 over 3. Then you will add it and at the same time subtract it. So 5 upon 3 squared, then plus this can be written as y plus 0 squared, then plus 1, which is equal to 0. So that is what exactly we are having. So here, to get this, as I said, you get 10 divided by 3, then you divide this by 2, which means you are multiplying by a half, then you square this one. So you add this coefficient here divided by 2, then squared. You add and subtract it at the same time, such that you don't create a difference in this expression. So when you look at this, this will be 5 over 3. So this one here will form one bracket, which is x plus 5 over 3, the whole of this squared. Actually, when you expand this, it means you are coming back to this given expression. Then plus this is y plus 0 squared. I will bring this one the other side, it will become negative 1, plus when I take this one the other side, it becomes 25 over 9. So that is basically what we shall have. So from here, we realize that this is x plus 5 over 3 squared, then plus y plus 0 squared, which is equal to, get the LCM is 9. So you will get negative 9 plus 25, which is actually 16. So this is of the form, x minus a squared plus y minus b squared, which is equal to r squared, which is actually the equation that represents the circle. So from here, then it means your a is actually negative 5 over 3, and then your b is actually 0. Then your r squared is actually represented by 16 over 9, which means your r is actually 4 divided by 3. So that will be r, and this r represents the radius. So what we can easily see is that the center is of the form AB, which means that our center will be negative 5 over 3 and what? And 0. So this will be our center. Then our radius is actually 4 over 3. So what do we conclude with? We shall conclude that the locus of Z is actually a circle. Is a circle of radius this and center that, is a circle of center negative 5 divided by 3 of 0 and radius which is 4 divided by 3 units. Let us now look at part B. Part B says use the Mover theorem to prove that cos 5x is equal to 16 cos power 5x minus 20 cos power 3x plus 5 cos of x. So to prove this, we shall be referring to the De Moivre theorem. So let us look at the solution. So we shall first of all refer to the De Moivre theorem by saying using De Moivre theorem, we shall have that when you have cos of x plus I sine of x, if this is to power 5, by De Moivre theorem, this is same as cos of 5x plus I sine of 5x. So by De Moivre theorem, we can write this. Our interest is to get cos 5x, and it must be equal to this. Now, since by De Moivre theorem this is true, then it means when we expand this, then we get to the real part, we equate it to cos 5x, then imaginary part can be equated to I sine 5x. So what we shall do is we shall first consider cos of x plus I sine of x to the power of 5. So we shall expand this. So to expand this, we can use different ways. One, we can use binomial expansion. Let us use the one for combination. So if I need to get what we call the coefficients, I will be using the combination. So the first one will be 5, combination 0. Then the term will be cos of x, the whole of this to the power of 5. Remember, this will be starting from 5, and it keeps on reducing the powers as this one is gaining the powers. Meaning, the first term here for I sine of x is to power 0. Then the next term, the coefficient will be 5 combination 1. Then the next term will be cos of x, but it will be to power 4. Then I sine of x will be to the power of 1. Plus, next will be 5 combination 2. That is the coefficient. Then the term will be cos of x to the power 3. Then I sine of x will now be to the power of 2. Then the next will be 5 combination 3. The term will be cos of x will reduce to 2. Then I sine of x will be 2, 3 now. Then the next one will be 5 combination 4. The term will be cos of x to the power now 1. Then I sine of x will be to the power of 4. Then the last one will be 5 combination 5. The term, the power for cos of x will be 0, and I sine of x will be 5. So that is how we can expand this. Now from there we shall have, let us now try to simplify this. 5 combination 0 is 1. So this will remain cos to power 5 of x. This is to power 0, so it becomes 1. Then plus 5 combination 1 is 5. So this will be cos to power 4 of x. Then times sine of x, then times I. I will also multiply by this I, because I sine x to power 1 remains I sine of x. Then the next one will be plus. We are now here, 5 combination 2. 5 combination 2 is 10. So this will be 10 cos to power 3 of x. Then this one will be sine squared of x, but this is also I squared. I squared is negative 1, so times negative 1. Then next we shall have 5 combination 3. 5 combination 3 is also 10. So 10, this will be cos squared of x. Then this will be sine to power 3 of x, but I is to power 3 here. So I to power 3 is same as I squared times I. But I squared we have seen is negative 1. So we shall remain with negative I here times negative I. Then the next one is, so we are done with that. 5 combination 4. 5 combination 4 is actually 5. So we shall have 5. Then cos of x. Then sine will be to power 4. Then I will be to power 4. So I to power 4 is same as I to power 3 times I. But I to power 3 is actually negative I. Then times I. So I times I is negative 1. So this will give us positive 1. So this is times 1. Then lastly, we shall have 5 combination 5 cos to power. Cos is to power 0. So we shall remain with I sine of x to power 5. So we shall add there. We shall add there sine to power 5 of x, but I is to power 5. So I to power 5, it means the same as I to power 4, the same as I to power 4 times I. But I to power 4 we have seen is 1, so this will remain of I. So that is what we shall have. So we are trying to simplify this. Let us have the terms without I. So we shall have cos to power 5 of x. Then this one will be minus 10 cos to power 3 of x, then sine squared of x. Then which one else? We are having this. We are having that. Then we also have this one here, which is plus 5 cos of x, then sine to power 4 of x. And those that are containing I, we shall pull I out. We shall have this. That is 5 cos to power 4 of x, then sine of x. Then the next one is this. So this one here is actually 10 cos to power 2 of x. Then there is a minus, so we shall consider that as a minus at once. So this will be minus 10 cos to power 2x, then sine to power 3 of x. Then we shall add there this one here, that is sine to power 5 of x. That is basically what we shall have. It is very clear that this expression is equal to this. But from this given equation 1, we have cos of x plus I sine of x to the power 5 equaling to this. So meaning that where I have this expression, I can place there cos 5x plus I sine 5x. So that is what exactly we are going to do. So where there is this, we are placing there this given expression, and we equate it to this same expression. So that is what we shall do. And it is clear that cos 5x plus I sine 5x will be equal to this given expression. Now, after that, we shall be comparing on both sides. So we shall compare. We shall be now dealing with comparing on both sides. So when we are comparing both sides, we shall have to look at the real parts and imaginary parts around. So the real part for this expression to be equal to this, it means the real part must be equal to the real part. The imaginary part must be equal to the imaginary part. So when we do that, it means we shall be able to obtain our cos of 5x, which is equal to cos to power 5 of x minus 10 cos to power 3 of x, then sine squared of x, then plus 5 cos of x, then sine to the power of 4 of x. So our interest is to get cos, but of course, when you are comparing, it means sine 5x will be equal to this expression, and cos of 5x will be equal to this whole expression. That is the expression that is not containing the this I here. So this is the real part, and this one here is the imaginary part. So we shall be equating the real parts around, and since our interest is in this, we shall forget about the this one here that is corresponding to sine 5x. So let us deal with this. This is where our emphasis is. Now, cos 5x is equal to this, but when you look at what we need to prove that cos 5x is actually this expression here. When you look at this expression, is actually not containing any sign. So we need to get rid of the sign function. Now, to do that, let us maintain cos to power 5 of x minus 10 cos to power 3 of x. We need to eliminate sign. So let us place sine squared in terms of cos. That is 1 minus cos squared of x. Then plus 5 cos of x. We need to also eliminate this, but we can write this first as sine squared of x to the power of 2. So this will be cos to power 5 of x minus, I will multiply this inside, 10 cos to power 3 of x, then plus 10 cos to power 5 of x, then plus 5 cos of x. I want to get rid of this, so I put the equivalent expression for sine squared, but in terms of cos, which is 1 minus cos squared of x. This is to power 2. So this will give us this one, and this will give us 11 cos to power 5 of x. This will be minus 10 cos to power 3 of x. Then plus, we will multiply this one inside here. Now, before that, let us first expand this. That is 5 cos of x into 1 minus 2 cos squared x, then plus cos to power 4 of x. I hope you know how to expand a minus b squared. This will be a squared minus 2ab, then plus b squared. So that is exactly what we are doing here. 1 squared minus 2 times 1 times cos squared, which will give us that. Then b squared, that is cos squared of x again squared, which will give us that. So let us try to simplify this further to have 11 cos to power 5x minus 10 cos to power 3x, then plus, you multiply this one inside, 5 cos of x minus 10 cos times cos squared, that will be cos to power 3 of x. Then this multiplied here will be 5 cos to power 5 of x. So simplifying this further, this is cos to power 5, this is cos to power 5, giving us 16 cos to power 5 of x. This is cos to power 3, cos to power 3 minus 10 minus 20 cos to power 3 of x, then plus this is 5 cos of x. So looking at this and what we exactly have when we look at this and what we need, what do we need? We need 16 cos to power 5 minus 20 cos to power 3 plus 5 cos of x, and that is exactly what we have got here. So that is 16 cos to power 5 of x minus 20 cos to power 3 of x, then plus 5 cos of x, and this will be the required expression. Yeah.